Welcome to Keystone Review video number 5. This one is all about relations and functions. Question number 1. A graph of a relation is shown below. And you can see the graph, it has 4 sides, 4 line segments in it. The question is, removing which line segment from the graph would make a relation a function of x? So we want to take the relation and make it a function. The key here is to decide what a function is. So if you remember a function, the definition is that for each x value, you only have one y value. One of the ways we can test for a function is with the vertical line test. So remember, we're going to draw some vertical lines. Okay? If we draw those vertical lines, and I know mine are a little wavy, but you get the point. So if we look at vertical lines, we can see that each vertical line goes through 2 points, 2 other lines. So in order to make this a function, we only want each vertical line to go through 1 point or one other segment. We can do that quite easily by taking this segment here on the bottom and eliminating that one. If we eliminate that one, then we have a function. So that one is from those 2 endpoints there. So -4, -2. So -4, -2 is one endpoint, and the other endpoint is 4, -3. So from -4, -2 to -4, -2, and 4, -3. That looks like D is the correct answer. A, B, and C are the other 3 segments. If we eliminate one of those, we still have 2 points going through our vertical lines. So remember the vertical line test as you check for functions. Question number 2. The set of ordered pairs below is a relation. Which relation has the same domain as the given relation? So if you remember, relation is just your ordered pairs, your set of ordered pairs. The domain is your set of x values. So the set of x values, we have 0.5, we have 1.5, 4.0, which is the same as 4, and 6.5. So we want to see which of the choices has the exact same x values. We don't care what the y values are. So x values. In the first one, we have 1, which is not on the list. So we can eliminate that. In B, we have 0.5, which is on the list, 1.5, 4.0, and 6.5. It looks like B. Let's just double check the other ones. C, we start with a 2. That's not on our list. D, we start with -1, and that's also not on our list. So B is the correct answer for number 2. Just remember that you have domain, and the range then is your y values. So you might get questions on either the domain or the range values. Question number 3. A teacher buys some pencils. He buys 2 pencils for each of his students. He buys 10 additional pencils. Each pencil costs 10 cents. How long do you think those pencils are going to last? 3 days. Which equation describes the total amount of money, y, in dollars, that the teacher spends on pencils as a function of the number of students x he has? In other words, write an equation for the pencils. Okay, so he buys 2 pencils for each of his students, and he buys 10 additional pencils. Okay, so number of students is X. So he buys 2 pencils per student. Okay, so 4 each, remember, means we're going to multiply. So that gives me a 2X. So one of these equations has to have something about 2X or something. All right, he buys 10 additional pencils, and each pencil costs 10 cents. So we have to work that into it too. So 2 pencils times 0.10 times the number of students, and then plus 10 pencils, that's his additional pencils, times 0.10 gives us money. Well, 2 times 0.10 gives us 0.20, and 10 times 0.10 gives us 1. So he spends $1 on those 10 additional pencils. So obviously A and B are not correct because they don't account for those additional pencils, which are just an add-on number. Since he buys 2 pencils per student, that means that C is the correct answer. D is not the correct answer because that looks like he's only buying 1 pencil per student. Okay, so make sure that when you're asked things like this, decide what you're looking for. So why is the amount of money? So we've got to incorporate that 10 cents per pencil in. Okay, last question, number 4. The table below represents a function of x. So which equation describes the function? There are lots of different ways you could do this. One way would be to take our x value, substitute it in, and see if it makes sense with the y. So I'm going to do that, and if I do that with the first line and it doesn't work, we know that's not the right equation. So for A, we have -2 times 4 plus 12. Well, -2 times 4 is -8. -8 plus 12 gives us 4, but that's not 16. So A is not correct. So let's look at the second one. -2 times 4 plus 24. So that gives us -2 times 4 is -8 plus 24, which gives us 16. So that one works. We need to make sure that it works with everything. So we're going to try it with the other ones. Let's just verify that C and D are not good answers. That might be easier to do than verifying the other lines in our table. So 2 times 4 plus 12. 2 times 4 is 8 plus 12 is 20, which is not 16, right? So that C is not correct. Then we have 2 times 4 plus 24. 2 times 4 is 8 plus 24, which gives us 32, which is not equal to 16. So D should not be correct. And then if we look at all the other choices, the other lines in our table, let's just verify. So -2 times 6 plus 24. -2 times 6 is -12 plus 24 equals 12. So 12 works. -2 times 8 plus 24, that's -16 plus 24, which is equal to 8. So 8 checks out. And -2 times 10 plus 24, so that's -20 plus 24, which equals 4, which also checks out. Sometimes on questions like these, you might have 2 equations that work in a particular line. So you really do have to go back and double check the other lines as well. In this case, it was easy because only one of them worked with the first ordered pair, the first set of numbers. But go back and double check. So in this case, B is the correct answer. I hope this covers enough of the functions and relations for you. If you're having trouble with these, if you're struggling through these, go back and double check some of the work that we've done in class. And as always, ask questions and come see me after school. Thanks.